If we have similar triangles, then corresponding sides are proportional. If we have similar triangles, then corresponding angles are congruent. Given the two triangles are similar, angle A is congruent to angle D because similar triangles implies corresponding angles are congruent. If we have similar triangles, then AB is to DE the same way that AC is to DF because similar triangles implies corresponding sides are proportional. If we have similar triangles, then corresponding sides are proportional. And then if we were to cross multiply, which we now call the means extremes product theorem, we would get the product of AB and DF is equal to the product of AC and DE. So we're going to call this means extremes product. No, you may not shorten it beyond that. Here we are given that BD is parallel to CE. We can say then that ABD is congruent to angle C because parallel lines implies corresponding angles are congruent. And we would know that angle ADB is congruent to angle E for the same reason. Which would make the two triangles similar by angle, angle. And then we have similar triangles, which implies corresponding sides are proportional. And then we can cross multiply or use the means extremes product theorem. We can say we can use the means extremes product theorem to say that AB times CE is equal to AC times BD. This is a shadow problem, and I promise that you will see these on the exam. While strolling one morning to get a little sun, Judy noticed that a 20-meter flagpole cast a 25-meter shadow. Nearby was a telephone pole that cast a 35-meter shadow. How tall was the telephone pole? Inherent in this problem is the assumption that the objects are perpendicular to the ground and that the angle of the sun, pretend it's blue, is so far away that the angle is essentially the same. The sun is so far away, the angle is essentially the same. So we can say the two triangles are similar by angle-angle similarity. So then we could say x is to 35 the same way that 20 is to 25. Personally, I prefer to work with smaller numbers, so I'm going to reduce this fraction. 5 goes into each number. Then 4 times 35 equals 5x, or x is 28 meters. Let's talk through some of these. If angle C is congruent to angle F, AB is perpendicular to BC, DE is perpendicular to EF, Right angles are congruent. So the two triangles are similar. The two triangles are similar by angle, angle. Then the sides would be proportional, because if you have similar triangles, then corresponding sides are proportional. In problem 2 here, angle X is congruent to angle ZBA. Angle Y, actually no, angle Z is congruent to itself by the reflexive property. Therefore, triangle ZBA is similar to triangle ZXY by angle, angle, and then similar triangles implies corresponding sides are proportional. In problem 5 here, we're given that the triangles are similar. So that would be our step 1. Our step 2, we could say, to write this out, look for the sides that are in one triangle. So NO is to NP the same way that RS is to RT. And then by the means extremes product theorem, we could prove the conclusion. Here we are given parallel lines. Then we know corresponding angles are congruent. So triangle SWZ is similar to SXY. We could have used the reflexive as well. And then WS is to WZ the same way that the large side XS is to XY, because similar triangles implies corresponding sides are proportional. And then we can reach the conclusion through the means extremes product theorem. Let's look at another shadow problem. Susie went for a walk. As she walked downtown, she wondered, how tall is that building? She was able to estimate it that it casts a 75-foot shadow. She noticed that a nearby tree that was 10 feet tall cast a 15-foot shadow. Assuming the sun's angle is a constant, how can she estimate the height of the building? X is to 75, the same way 10 is to 15. Again, I'm going to reduce. 3x equals 2 times 75, or what times 3 gives me 75? Isn't that 25? So 2 times 25 is 50. For number 9, you have to draw your own image. There's my tree, casting a 30-meter shadow. A nearby flagpole casts a 24-meter shadow. The flagpole is 20 meters high. So now I can say 20 is to 24, the same way that x is to 30. I'm going to reduce. 4 goes into each. And then 6 times 5 is 30, so 5 times 5 is 25. If two similar kites have perimeters of 21 to 28, remember perimeter is one-dimensional, it's length only. They want to know the ratio of the sides, also length only, one-dimensional. All I would need to do is reduce the fraction. To show that AB is parallel to DE, on triangle ABC, I have lengths 8, 4, and 6. On triangle EDC, my lengths are 20, 10, and 15. From 8, 4, and 6, I can factor out a 2. I get 4, 2, 3. From 20, 10, and 15, I can factor out a 5. So I get 4, 2, and 3 again. Right here are the original sides, so that we could say AC is to EC the same way that AB is to ED, the same way that BC is to DC. And all of those will have a ratio of 2/5. Here we have a trapezoid, and we know the bases of a trapezoid are parallel, which will mean alternate interior angles are congruent, which would mean triangle CED would be similar to triangle AEB, and then AE is to AB the same way that CE is to DC. And then by means extremes product, we could finish our proof. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.